Second question, calculate arithmetic mean from the following data. Weekly wages 0 to 7, corresponding frequency 8. Weekly wages 8 to 15, corresponding frequency 15. 16 to 23, corresponding frequency 34. 24 to 31, corresponding frequency 20. 32 to 39, corresponding frequency 18. 40 to 47, corresponding frequency 5. You have to draw a column like this. Weekly wages 0 to 7, corresponding frequency 8. Then find mid value. X is equal to 7, 0 plus 7 divided by 2, which is equal to 3.5. Similarly, 8 plus 15 divided by 2 is equal to 11.5. 16 plus 23 divided by 2 is equal to 19.5. 24 plus 31 divided by 2 is equal to 27.5. Like that. Then find D. D is equal to, at first we have to find assumed mean, that is capital A. Then that is 19.5. Then D is equal to x minus 19.5 divided by 8. That is 3.5. At first x 3.5. 3.5 minus 19.5 divided by 8 is equal to minus 2. Then D is equal to 11.5 minus 19.5 divided by 8 is equal to minus 1. Then 19 minus 19.5 minus 19.5 divided by 8 is equal to 0. Like that we got all the values 1, 2, 3. Then FD, F into D is equal to 8 into minus 2 is equal to minus 16. 15 into minus 1 is equal to minus 15. 34 into 0 is equal to 0. 20 into 1 is equal to 20. 18 into 2 is equal to 36. 5 into 3 is equal to 15. Then find summation. Summation FD is equal to, because we had to add minus values, go to 31, then plus value 71. Then summation FD is equal to 40. Then summation F is equal to 100. Then find arithmetic mean. The equation of arithmetic mean x bar is equal to, in the case of frequency data, capital A plus summation FD divided by n into C. Here C is the 8. In this column we got as in your C. Then A 19.5. 19. Substitute all this value, we get 19.5 plus summation FD 40 divided by 100 into C. 14 by 100 into 8, which is equal to 19.5 plus 0.4 into 8 is equal to 19.5 plus 3.2 is equal to 22.7. Welcome to my channel. Properties of arithmetic mean. The arithmetic mean is preserved under a linear transformation of scale. That is, if xi is changed to yi by the rule yi is equal to a plus b xi, then y bar is equal to a plus b into x bar, which is also linear. Proof. First we have to take let yi is equal to a plus b xi. By giving summation on both sides, summation I is equal to 1 to n yi is equal to summation I is equal to 1 to n a plus b into xi. Then you have to put divide by n on both sides. Summation I is equal to 1 to n yi by n is equal to summation I is equal to 1 to n a plus b into xi divided by n. We know that by the equation of arithmetic mean, summation I is equal to 1 to n yi by n is equal to y bar, and summation I is equal to 1 to n xi by n is equal to x bar. Then we get here y bar is equal to a plus b into x bar. Second property, the mean of a sum of variables is equal to the sum of the means of the variables. Then third property, the algebraic sum of the deviations of observations from arithmetic mean is 0. That is, summation xi minus x bar is equal to 0. ഓരോ ഡീവിയേഷൻസിൽ നിന്നും അരിത്തമെറ്റിക് മീൻ കുറച്ചാൽ അതിൻ്റെ സം എടുത്താൽ 0 ആയിരിക്കും. Third property, the algebraic sum of the deviations of observations from the arithmetic mean is 0. That is, summation xi minus x bar is equal to 0. Proof. Let x1, x2, etc. xn be a set of observation. Let x bar be its mean. Then summation I is equal to 1 to n xi minus x bar is equal to split that summation summation I is equal to 1 to n xi minus summation I is equal to 1 to n x bar. We know that x bar is equal to summation xi divided by n. Summation I is equal to 1 to n xi by n. So first quantity becomes nx bar. Then second one, x bar into summation I is equal to 1 to n 1. Summation I is equal to 1 to n 1 is n. Therefore it is equal to nx bar minus nx bar is equal to 0. One example, let the observation of variable be 2, 3, 4, 5, 7. The arithmetic mean is 4.2. The deviations of each observation from the arithmetic mean is first one, 2 minus 4.2 is equal to minus 2.2. Then 3 minus 4.2 is equal to minus 1.2. And 4 minus 4.2 is equal to minus 0.2. And 5 minus 4.2 is equal to 0.8. And 7 minus 4.2 is equal to 2.5. Then adding same sign, and we get 3.6 minus 3.6. Then the sum is equal to 3.6 plus minus 3.6 equal to 0. That is our property, summation xi minus x bar is equal to 0. Fourth property, the algebraic sum of the squares of observations from the arithmetic mean is always minimum. That is, summation xi minus x bar whole square is always minimum. The algebraic sum of fourth property, the algebraic sum of squares of observations from arithmetic mean is always minimum. That is, summation xi minus x bar whole square is always minimum. ഒരു ഫംഗ്ഷൻ മിനിമം ആവണമെങ്കിൽ a function f of x is said to be minimum when f dash of x is equal to 0 and f double dash of x greater than 0. Using this method, we can prove summation I is equal to 1 to n xi minus x bar whole square is minimum. Let x1, x2, etc. xn be the set of n observations and x bar be the mean. Consider a function f of x naught is equal to summation I is equal to 1 to n xi minus x bar xi minus x naught whole square. We had to prove that f of x is minimum. Then x naught is equal to x bar. First we had to find x dash of x naught is equal to 0 implies f of x naught is equal to summation I is equal to n xi minus x naught whole square. We had to find its derivative 2 into summation I is equal to 1 to n xi minus x naught into minus 1 is equal to 0. This implies summation I is equal to 1 to n xi minus bar is equal to 0. Summation take inside summation I is equal to 1 to n xi minus summation I is equal to 1 to n x naught is equal to 0 implies n x bar minus n x naught is equal to 0 implies x bar is equal to x naught. Also f double dash of x is equal to f dash of x ഒന്നും കൂടി ഡെറിവേറ്റീവ് കാണാം. f double dash of x is equal to 2 into summation I is equal to 1 to n 0 minus 1 which is equal to 2 into summation I is equal to 1 to n 1 which is equal to 2 into n which is a positive quantity. That is, f of x naught is minimum when x naught is equal to x bar. It is our property. The algebraic sum of squares of observations from arithmetic mean is always minimum. That is, summation I is equal to summation xi minus x bar whole square is always minimum. Fifth property, if n1 observations have an arithmetic mean x1 bar and n2 observations have an arithmetic mean x2 bar, then the arithmetic mean of the combined group of n1 plus n2 observations is given by x bar is equal to n1 into x1 bar plus n2 into x2 bar divided by n1 plus n2. More general